All right, so we're going to be talking, there's a lot of information today actually on day 5 stuff about standard position, what a coterminal angle is, and an introduction to radians. So we're going to jump straight in, and I'm going to let you do the warm-up on your own. So angles can be measured in both degrees or in radians, just like a length of something can be measured in both feet and in meters. It's just two different ways of measuring the same thing, two different units. So you're the one that we seem to be most comfortable with is in degrees, but there's also another way to measure how big angles are, and that's in radians. By the way, I'm not sure how many videos this is going to take, but it's probably going to be fairly long because this is a lot of important information. So if I'm going to draw these angles, we are in standard position currently. So standard position, again, is where the initial side is on the x-axis, and then I'm going to open it up to some finishing terminal side. So how much am I opening this up? Well, it depends, right? So that would be more than 360 degrees if I continued on. Anyway, starting from the x-axis, if I'm to draw a negative 45-degree angle, the negative indicates that it's going to be moving in the in the clockwise direction. If it's negative, the negative and positives just mean that it's which direction is it opening. Is it opening in the negative direction, which is how a clock moves, or is it opening up in the positive direction, or that would be counterclockwise? So for a negative 45-degree angle, okay, I know from here all the way down to there would be a negative 90-degree angle. I just want to go negative 45 degrees. Now, how do I know which way I opened it up? Well, that's why you have to have an arrow indicating which direction that you opened it. So I opened it going that way, giving me a negative 45-degree angle. 225 degrees. So if this is 90 degrees, that's positive 90 because I'm going counterclockwise. That's 180 degrees. Plus another 90 would be 270 degrees. Oh wait, I'm somewhere between 270 degrees and 180 degrees. So 225 degrees is going to be somewhere between those two. Well, how much further do I have to go? If I subtract off 180 degrees here, let's see here, that would be, what, 45 degrees? So if I move this 180 degrees, okay, here we go, there's 90, 180 degrees, I need an additional 45 degrees to get to that entire 225 degree angle. Oops, sorry, I need to pause this. Okay, so this angle, that's the reference angle. This angle right here, we decided was a 45-degree angle. To go to 390 degrees, okay, since it's positive, I'm going to have to move that in the counterclockwise direction. So it's 360 degrees. How much more do I need to go to get to 390 degrees? I need to go an additional 30 degrees. So how did I really make this 390 degrees? Well, I've got to draw the arrow. I went a full circle for 360 plus an additional 30 degrees. So that entire angle is 390 degrees. And then my reference angle here, that's the angle made that terminal side in the x-axis, that reference angle is the 30-degree angle. So coterminal angles are angles that have the same initial side and same terminal side, but I'm getting there in a different direction and getting there in a different way. So, for example, on this one, like I must have started here and I opened it up to here. How do I know that? Because that's what the picture is showing with the angle measure there. So, what's a different way that I can start on with this one and end at this terminal side, but not taking this exact same direction to get there? Well, I could have gone this way instead, right? That also would have started in the same place and would have ended with the same terminal side, but it just would have been a different way. So this would be a negative coterminal angle. Well, how big is that negative coterminal angle? Well, I know that to get all the way around would have been a full 360 degrees. But then if I take the angle measure and I subtract 360 degrees from that, that should be this negative coterminal angle. If I want to know what's a positive coterminal angle, again, I got to start here. I have to end at the same terminal side, but I need to get there in a different positive way. So what if instead, what if I opened up and I went, oh wait, I can't stop there because that would have been the same as the original angle. But what if I kept going and then I decided to end? That would also be a positive angle. So this would be a positive coterminal angle. And I should write coterminal. It almost looks like cotangent. Coterminal. So how would I figure out how many degrees that coterminal angle is? Well, however big the original angle was, I just added on a whole nother circle onto that. So it would be whatever the angle measure is, theta, plus 360 degrees. So if I want to draw an angle that's 30 degrees in standard position. All right, standard position. Standard position. Let's do this. Okay. So if I take that and I'm going to open it up 30 degrees. Okay. There's my 30-degree angle. How did I get there? I went like this. So I'm just calling that theta. Again, theta just means, hey, here's an angle measure, and I'm calling it theta. Find a positive and negative coterminal angle to this 30-degree angle. Well, what's a different way I could have started in that same place and ended on that same terminal side? Well, I could have gone this direction instead. I'd have started in the same place and ended in the same place, but got there in a different manner. So how big would that angle have to be? Well, a full circle is 360 degrees. And I'm just short by 30 degrees, so 360 degrees and 30 degrees, that difference would be 330 degrees. But I needed it to be negative. That's why I actually did 30 minus 360, because this is going in the clockwise direction, that angle is going to be a negative angle. So that is negative 330 degrees for that. I should draw another arrow, but that's what that angle measure is that's in blue. So what's a different positive coterminal angle? Again, I got to start at the same side, I got to end at the same place, but now I got to open it up in the positive direction, which means I got to open it up in the clockwise or counterclockwise direction. So that would be like this. So how big is that angle measure I just made? Well, I went one full circle, right? It went one whole circle, so that's 360 degrees. And then how much did I go past that? I went an additional 30 degrees past that. So that angle measure would have to be 360 degrees plus an additional 30 degrees for that reference angle, or a total of 390 degrees. So that's my positive coterminal angle to 30 degrees, and then negative 330 degrees is my negative coterminal angle. Well, you could, if you wanted to, you could go around and do an additional 360 degrees. Hey, what if I wanted to do that? Then what would my coterminal angle be? Well, add another 360 degrees to that, and that'd be 750 degrees is an additional positive coterminal angle. Hey, if I wanted to go around another circle just because I can, I could subtract an additional 360 degrees from 330 degrees, negative 330 degrees, and get negative 690 degrees would be an additional negative coterminal angle. That would just meant that I would have gone around the circle one more time. So you can go around as many times as you want to, but the smallest negative coterminal angle would have been negative 330 degrees, and the smallest positive coterminal angle would have been that positive 390 degrees. So if you draw a circle with your compass, okay, and make sure it's not too small, find the length of your radius with a piece of string and see how many radians fit around the perimeter of the circle. Literally pause the video, try that out. Okay, so you are going to take your circle. It's a very, very disproportionate circle. Here's the radius of my circle, and then I'm going to take a piece of string from the distance from here to here, the length of that radius, and I'm going to fit it around my circle, okay? If I take my string and I fit it around, that's apparently how long it is. So this radius length, this length of this arc is the same length as the radius of this circle is. And then see how many of these radiuses fit around your entire circle. So go ahead and pause the video and see what you come up with. All right, hopefully you actually paused the video, and hopefully you also found that it took about 6 radiuses to fit around the entire circle. It actually wasn't exactly 6 though, was it? It should have been a little bit more than 6 radiuses. So when you go through, okay, so we're gonna mark these radians on our circle. Let's see here, creative pen. All right, so if I was to take the length of my radius and I was to start it here and end it with my string, it probably would have been about that long. So if this is 1 radius, okay, so we're just, how long is 1 radius? I don't know, however big you made your circle. Then this distance from there to there is also 1 radius. And then if I keep doing that, okay, so then I go a second radius. Second radius, okay, so I fit my string around and it ends about there. Then this is 2 radiuses, right? This is an additional radius. So really from, let's do it this way, from here all the way to the beginning, this is 2 radiuses it took to get there. And I keep going, and then I should have gotten, well, 3 radiuses should have been almost a full circle, but not exactly a full circle. Should have been about like right there. So if I was to extend this radius to a full diameter, it should have been a little bit more than 3 radiuses. Huh. If you think of a number in math that happens a lot, that's a little bit more than 3. How about pi? Pi is a little bit more than 3, right? It's like 3.14 something radiuses, okay? Anyway, let's see. If I keep going though, so we'll ignore that for now, and keep going another radius, and another radius, and another radius. Oh, looks like it's just a little bit short, or I'm sorry, a little bit long of 6 radiuses. So for here, that would be 3 radiuses. This is 4 radiuses, 5 radiuses, 6 radiuses, and then there's this little bit left. So this is called a radian. The angle that's made between 2 radiuses is called a radian. Well, how many degrees is that? It doesn't matter, okay? Don't worry about it. It's just a different way of measuring how big this angle is. Well, what if instead I go 2 radiuses? How big is that angle measure? Well, we call that 2 radians is how big that angle measure is. That's why the word radian sounds a lot like the word radius. So to help you out here, this is just directly from Wikipedia. And so you drew your circle, you constructed your circle more like, with some given radius length, and then you took the radius and you're actually folding it along the circle. That's why I told you to take a string and see how many of these radiuses fit around. So that angle measure made by 1 radius is called 1 radian. And then if I take that and I go 2, that'd be 2 radians for the angle measure. 3 radians is not a full circle, a semicircle, but pi radians, 3.14-ish radians, goes halfway around the circle. So how much does it take to go 2 times around the circle? It takes 2 pi radians, right? 1 pi for half a circle, so then 2 pi for a full circle. That should kind of sort of make sense, right? So apparently right there, it took pi radians. It took 3.14-ish radians. So this little bit, or the part over here, when I went to 6 radians and then I added a little bit more, well, if half a circle is pi radians, then a whole circle would have to be 2 pi radians around. Or 2 pi radians, 2 times 3.14, it's about 6.28 approximately radians. So it takes a little bit more than 6 of these radiuses to go around an entire circle. Is there anything else on this page I needed? Nope. Okay, so let's think about 1 revolution. How many radians did that take? Oh wait, 1 whole way around the circle took a little more than 6. How much more? Oh yeah, it took 6.28 radians, or 2 pi radians, to go all the way around the circle. So how much does it take to go only halfway around the circle? Well, Oh yeah, that took a little bit more than 3 radians. Oh yeah, that's called pi radians. I'm going to go ahead and write that here, radians. So that's a little bit more than 3 radiuses. What if I only want to go a quarter of the circle? If this takes pi radians to get all the way to there, then what if I just want to go short to just a quarter of the circle? Well, it must be pi cut in half, right? Half of a pi. Oh, now we're getting tricky. What if I only want a sixth? If I want a sixth of the circle, so if somehow I was to break this up into 6 equal pieces, gosh, what would that even look like? Something like that. I don't know. No, that's terrible. That's terrible. Let's not even do that. I can't even do it. So if it takes 2 pi radians to get all the way around, and I only want to go a sixth of the way, how can I figure out how many radiuses that is? Oh, well, if it's 2 pi to get all the way around, and I want 6 equal sections of that, then a sixth of the way around must be pi over 3 radians. How about 1/8? Okay, same logic, 2 pi to get all the way around the circle, but I only want 1/8 of the way. Okay, well if it takes 2 pi to get all the way around the circle, and I only want 1/8 of that, then that would have to be pi over 4 radians. 1/12 of the circle. Are you catching the idea here? So 2 pi to get all the way around the circle, and I only want a 12th. 2 pi, and I need a 12th of that. That would be pi over 6 radians. Okay, let's talk about degrees. Degrees probably will be easy for you. So degrees, how many degrees is it to go once all the way around the circle? 360 degrees. Notice that on the degrees, like they have to put a degree symbol. If there is no degree symbol, they just write 2 pi. That's radians, okay? If they say 3.2, go ahead and sketch the angle that is 3.2. They're talking about 3.2 radians. So if that would be like, hey, if half the circle is pi radians, that's like 3.14 radians. I need a little bit more than that. That would be like 3.2 radians. So my angle in standard position would look like this, and that would be 3.2. How many radiuses does it take to go around? 1, 2, 3, and I need 0.2 more. Oh wait, that's 0.14 more. I need a little bit more than that. So that'd be 3.2. So they have to tell you if it's degrees, they have to put a little symbol there. If there is no units, then it's automatically assumed to be radians. They actually get really lazy and typically don't write radians on anything. But I just wanted you to see the radians just so you knew what I was talking about. So how much is it for half the circle? Half the circle is 180 degrees. How much is it for a quarter of a circle? A quarter of a circle has to be 90 degrees. This is not too bad. How about a sixth of a circle? Well, if one whole circle is 360 degrees, and I only want a sixth of that, then that would have to be 60 degrees. Oh, apparently pi over 3 radians is the same as 60 degrees. Or if I'm going 1/6 of the circle, it takes a little bit more than 1 radian, right? Pi is like 3.14, and I'm dividing that by 3. That's a little bit more than 1 whole radian. So to get to 60 degrees, it's a little bit more than 1 whole radian. So 1 radian here has to be a little bit less than 60 degrees. 1/8 of a circle. Okay, so if a full circle is 360 degrees and I need 1/8 of that, let's see here, 360 divided by 8, 4 goes into both of those, 90 over 2, 45 degrees, which kind of makes sense, right? If a quarter of the circle was 90 degrees, then 1/8 of a circle would have to be 45 degrees. Same thoughts with the radians. In radians, a quarter of the circle was pi over 2 radians, And if I want to cut that in half, well, pi over 2, and I want half of that, that would be pi over 4 radians for that angle measure. So that's why this one and this one, like there is an easy way to get from one to the other. 1/12 of a circle, so full circle is 360 degrees, divided by 12, that would be 30 degrees. So 1/12 of a whole circle is in fact 30 degrees. So how do I go between degrees and radians and degrees? This is your key. We know that 1 revolution is 2 pi. 1 revolution is also 360 degrees. So for every 2 pi radians, I have 360 degrees. Kind of like every 60 seconds gives me 1 minute. 60 seconds gives me 1 minute. And I can convert things that are in minutes. So if I have 3 minutes, how many seconds is that? Well, I can multiply that by the conversion. Well, every 60 seconds is 1 minute. Similarly, every 2 pi radians is 360 degrees. And then I can cancel my units here and figure out exactly how many seconds that is, which is 180 seconds, by the way. So if I can just use this ratio here, hey, every 2 pi radians gives me 360 degrees. So if I have something that's already in degrees, and I'm trying to figure out how many radians it is, like 30 degrees, how many radians is that? Oh, my degrees units will then cancel each other, and that will tell me how many radians that I have. So if I can multiply by 2 pi radians over 360 degrees, that'll convert from degrees to radians. So how do I go backwards? How do I convert from radians to degrees? We can divide by that number. True, easier would be multiplying by its reciprocal. Every 2 pi radians is 360 degrees. So when I have something that's in radians, let's see here, pi over 4. How many radians is that again? So pi over 4, this is in radians. How many degrees does that end up being? Okay, I forgot my degree symbol there. So, and then my pi's will cancel. 4 goes into 360 9 times. 9 divided by 2 is 4.5. So that would be, this should be 90. 90 divided by 2 would have to be 45 degrees. So apparently, pi over 4 radians is in fact exactly 45 degrees. So maybe you've noticed that this reduces. Hey, 2 pi radians over 360, like I can reduce those. That would be pi radians over 180 degrees. Same thing here. This reduces to 180 degrees over pi radians. Oh, well that's true too, right? We know that, okay, for every full circle, that's 360 degrees, or 2 pi. So half of a circle is 180 degrees, or it's 1 single pi. So for every 180 degrees, that's pi radians. For every pi radians, we have 180 degrees. So there's 1 pi radian, there's 2 pi radians, 3 pi radians, 4 pi radians, you get the idea, okay? Or you could count that all in degrees if you so desired. This would be 180 degrees, plus another 180, 360 degrees, plus another 180, I can't count that high, but you get the idea. So, let's take a couple of these. Let's see. So converting 4 pi over 3, oh, there's no units on this. Well, that's because they don't usually put radians when they're talking about radians. So if there's no units, assume that it's automatically in radians. And I want that to become degrees. How many degrees is 4 pi over 3 radians? Well, wait a minute. How did that work again? I know that every, 2 pi, what's my units, my skill factor? Every 2 pi radians is equivalent to 360 degrees. And every 360 degrees is 2 pi radians. I need the radians units to cancel. So if I multiply this by every 360 degrees is 2 pi radians, my radians will cancel, and then I'll have my answer in degrees. So 3 goes into 360, 120 times. Oh, my pi's will cancel here. 2 goes into 4 twice. 2 times 120, 240 degrees. So apparently 4 pi over 3 is 240 degrees. Are you watching closely? Isn't 4 pi over 3 the same thing as 1 1/3 pi? So how much is 1 pi? Oh yeah, half the circle is 1 pi, and if I go 1/3 more, that should be 1 1/3 pi radians, right? So if I want to convert that to degrees, hey, this is 180 degrees, and I need a third more, which would be another 60 degrees. 180 plus 60 degrees, that angle measure would in fact be 240 degrees. Just something to think about. Notice here your reference angle would be this 60 degrees. Just saying, okay? Or your reference angle in radians would have been 1/3 of a pi, because here would have been 1 pi and I needed a third more. So this would be 1/3 pi radians for that reference angle here. Just something to think about. Another one, let's see. How about convert, let's go 75 degrees to radians. 75 degrees to radians. So 75 degrees, I know that for every 180 degrees, how many radians is 180 degrees? Pi radians. Why didn't you multiply it by 360 over 2 pi? Because that's the same thing. Okay, so, oh wait, nope, this doesn't work out, because I need the radians to be on the numerator, and I need the degrees to cancel. So it must be multiplying by pi radians over 180 degrees. That is the biggest degree symbol I've ever seen. So if I cancel my degrees, and then what is that? 75 and 180. I'm going to cheat here and use my calculator. 75 divided by 180 and fraction. That's apparently 5/12. Now you don't have to write the word radians. Okay, if you have no units written there, I already know that that's in radians. This is 5/12 or radian. How about 0.63 degrees? Or 0.63, oh, there's no units on that. It must be in radians. So let's figure out how many degrees that is. So 0.63 radians, and I know that for every 180 degrees, I have pi radians. My units will cancel, and I'm going to need my calculator for this one. 0.63 times 180 divided by pi is 36.096 yada yada yada. So about 36.1 degrees is 0.63 radians. So what if I want to draw these angles and find one positive and one negative coterminal angle for each? Let's try number 4. So if I was to draw that angle, negative 11 pi over 4. Let's see, what is that as a mixed number? That would be negative 2 3/4 of a pi. What's the units on that? Radians. So if you count with me, wait, it's negative. What does that mean? That negative means that I have to open it up in the clockwise direction. So if I go, count with me here, okay, got to start here in the standard position, and I'm going to open it up clockwise. This would be negative 1 pi, negative 2 pi, and I need 3/4 more of a pi. It'd be somewhere about right there. There is negative 11 pi over 4 radians, or negative 2 3/4 pi radians. That's equivalent. Let's see here. Let's look at this reference angle. How big is that reference angle? I don't think they asked me for that, but let's just talk about it. How big would that reference angle have been? Well, remember, I went negative 1 pi, negative 2 pi, and then I went 3/4 of another pi. So how much is left must have been 1/4 of a pi. So that would be my reference angle. Wait, shouldn't it be a negative 1/4 pi? No, reference angles always have to be positive and always made with that terminal side in the x-axis. So that actually would be pi over 4. Do you know how many degrees that is? 45 degrees. Anyway, they are asking me though for one positive coterminal angle and one negative coterminal angle. So start at the same place, end at the same place, but find a different way to get there. Because I just went in the counterclockwise direction, that would be a positive coterminal angle. How many degrees would that positive coterminal angle be? I don't know. Oh, wait a minute. Do you remember? Do you remember that this reference angle was pi over 4? How much is it to get all the way from here to half a circle? Pi radians. So I have pi radians plus another pi over 4 radians. So I got 1 1/4 of a pi radians for that positive coterminal angle, also known as 5 pi over 4 would be one positive coterminal angle. You could also add another 2 pi to that, and that would also end at the same place and start at the same place, but that's probably the easiest one to find. Try not to do not do conversions of degrees. Don't, if it's in radians, do yourself a huge favor right now and start thinking of the problem in radians. Don't convert it to degrees. Oh, but degrees is so much easier. Yeah, well, if you keep converting all of these radians just to degrees, in order for you to graph them, you are going to be hurting yourself a lot later on. Trust me on this. If it's in radians, start practicing right now of thinking it in terms of radians. Don't convert everything to degrees. You are going to be very, very sorry later on that you didn't have that practice. Okay, I'm off my soapbox. Let's do a negative coterminal angle. Start at the same place, end at the same place, and just find a different way to get there. So that would be a negative coterminal angle. How do I know it's negative? Because I went in the clockwise direction. So how many radians is that? Wait, how many radians is it to get to a half a circle? Let's see here, to get to a half a circle, that would have been pi radians. Oh wait, but I didn't have a half a circle. I only had 3/4. Oh wait, I just answered my own question, didn't I? I had 3/4 of a radian, or I'm sorry, 3/4 of a pi, right? Half a circle would have been pi. I was short by pi over 4 radians. So how many radians do I have? I have 3/4 of a pi radians. Oh wait, but I went in the negative direction, so that negative coterminal angle would be negative 3/4 pi. All right, that's it for Trig Day 5. Hope you enjoyed. Please bring me lots of questions.